Hey, welcome back to your favorite technical mathematics class. We're going to look at simple formulas and literal equations today, manipulate those. For example, a literal equation is simply where you got an equation with more than one variable. So where we had our voltage is our current times our resistance. Let's look at some here. So we're going to solve the formula for the given variable. So we have AY plus B equals 2C, and we're just solving for B. So, what would you do if you were solving for B? Well, you'd get rid of the AY. Well, how do you get rid of the AY? Because AY is being added to B, so you subtract the AY. That's all you gotta do here. So now B is solved for us. 2C minus AY, since you can't combine those. Let's do some other ones here. You've got conductors, material that permits the flow of electrons, resistance is measured, so it's just the resistance to that flow at a given temperature. The resistance of materials depend on the type, length, cross-section of the material is given by the following literal equation. All we care about mathematically is this literal equation, and we're going to solve for, it says to solve for A. First of all, we got to get A on top, on the bottom. So let's multiply both sides by A to make sure we get this A on top. And again, we're solving for A. So we've got AR equals this P times L here. So this is for a wire's cross-sectional area, the A. We're solving for the A, so get rid of the R now. So we divide, since right now it's being multiplied by the A, we do the opposite division. So A equals PL times R, whatever those definitions were, but we're solving for A. That's what we're concerned about here. Now with this one, we're solving for L, so we got M equals R times L minus X. Well, first of all, you got to get that L out, so let's go ahead and distribute that R through, so we have RL minus RX, and don't forget we're solving for that L there. So let's get rid of the minus Rx part. So we add the Rx to both sides. We're just getting rid of that here. So that's gone. So we got M plus Rx equals RL. Let me bring it up here. So RL equals M plus Rx. And remember, we're solving this literal equation for L here. So go ahead and divide by R. If you divide by R on this side, you got to divide by R on that side, so that entire side. So L equals M plus Rx over R. Or if you wanted to, that R right here is being divided, that M plus Rx, you could write it M over R plus Rx over R, because that R there is a common denominator of both of those terms, right? So either of those would be fine. Here's another one. We're going to solve for B. So we got Q equals Ka parentheses B minus C. Again, we're going to solve for that B there all over L. Let me get rid of this fraction here for a minute. I'm going to multiply both sides by L. So we got QL equals Ka. Now I'm going to go ahead and distribute. So KAB minus the KAC. Again, we're solving for that B, so let's go ahead and add that KAC to both sides. Get rid of that. So we've got over here, we've got QL plus KAC equals KAB. Again, we're solving for that B right there. So just get rid of the KA. Since it's being multiplied by the B, we're going to divide it. So that means each of these, again, will be divided by Ka, each of those terms, but we can just put it all over that. So B equals QL plus KAC, C all over Ka. Or if you want to write that as QL over Ka, since that's a common denominator, plus KAC over Ka. So here's one answer. But in this case, you would want to go ahead and cancel those Ka. So QL over Ka plus C. That's another form. Either of those are fine. Okay, now here we're going to solve for S1. Now notice there's two S1s. There's one here, there's one there. Let's go ahead and distribute that and collect all your S1s on one side when you're solving. 3AS1 plus 3A squared. So again, get all your S1s on one side. So we have 3AS1. I'm going to subtract the AS1 from that side, from that side. And then I'm going to take this over. I'm trying to get my S1s together. So I got CS subscript 2 minus 3A squared equals 3AS1 minus, oops, I forgot to put minus on that, minus AS1. So what's 3A minus a 1A is 2A S1s. Okay, we're solving for S1. So at this point, now we can just get rid of the 2A. So divide both sides by 2A. 2A. And by the way, that was 3A squared, not 3A subscript. So we've got S1 equals CS subscript 2 minus 3A squared all over 2A. Solve for S subscript 1. Alright, well, we'll see you guys soon.